In this lesson, we are going to discuss relative mass. Now, relative is just a word meaning compared to. And that's in a scientific term. So, if I say compared to an ant, Mr. Kilgore is relatively large. But compared to an elephant, Mr. Kilgore is relatively small. What we can do is we can use this to set a relative unit scale. And this was what was done historically a lot. And you all are familiar with the term foot. And historically, what a foot was, that was the length of the king's foot. Unfortunately, for people doing measurements, the length of the king's foot changed when there was a new king. So it should be a standardized scale, and that's what we're trying to do right now. But let's bear with me here. So let's say if it takes 20 Mr. Kilgores to make the mass of one elephant, what we can say is we can use Mr. K as a relative mass, as a reference. So, one elephant, say, has a mass of 20 Mr. Kilgores. So we can use Mr. Kilgore as a weight term. I don't know if that's true or not, but assume it is. And if I have 40 Mr. K's worth of elephant, there must be 2 elephants. I can use this as a ratio of number, too, if I have that relative. And one thing that I do want to note that's important, if there is 20 times the mass of Mr. K's in elephants, I must have the same number of Mr. K's and elephants. So, like in this problem, if I have 40 Mr. Kilgores of elephants, I have 2 elephants. So, if I have 20 times the number of Mr. Kilgores compared to elephants, I must have the same number. If I had 60 Mr. Kilgores worth of elephants, I must have 3 elephants. And so if I have, so we can use that as a scale. So it's like similar to cups and volumes when you're cooking something. If I have a recipe that, for every 1 cup of water needs 2 cups of rice, that's going to work for gallons too. If I need 2 gallons to make 2 gallons of rice, I'm going to need double that amount of water, 4 gallons. So, think about that. But how do we use this in terms of chemistry? Why is this relevant? Well, it's actually, the periodic table is based on a relative scale, where carbon-12 has exactly a mass of 12. So what we can say is magnesium-24 is twice the mass of carbon-12. And hydrogen-1 is 1/12. The mass of carbon-12. So the periodic table is a relative scale compared to carbon-12 having exactly a mass of 12 AMU. Now, we can apply this to lab. So say, for instance, we have a 2-gram sample of magnesium oxide that decomposes to 1.21 grams of magnesium. We can actually set up a relative scale. So since 0.79 grams of oxygen must have left. We all talked about the sample of, the conservation of mass. And we have a 1-to-1 magnesium to oxygen ratio in magnesium oxide. We can figure that out from the formula. We can calculate the relative mass of magnesium compared to oxygen. So, if we have 1.21 grams of magnesium compared to 0.79 grams of oxygen, that's equal to 1.5. So what we can find out is magnesium is 1.5 times heavier than oxygen. So if oxygen has a mass of 16 AMU, AMU meaning atomic mass unit, magnesium must be 1.5 times as heavy. And have a mass of 24 AMU. So that's how we can look at this thing, and we're actually in the relative mass lab. We will be applying this. So, understand what it means. Relative just means compared to something else. Normally, we will compare to the smaller of the objects, like we did in What's the Count. So this is we're going to see this a couple times in activities and labs.